I'm Bidan Chitri and I'm doing a presentation on the topic binding energy curve and stability and radioactivity. So I'll be covering the topics binding energy, explanation of nuclear binding energy and stability, radioactivity, radioactivity types, alpha particles, beta particles, and gamma rays. Nuclear binding energies. When the protons and neutrons combine to form a nucleus, the mass disappears, which is also called mass defect, which is denoted by del M. The mass that disappears is converted into equivalent amount of energy, that is del mc square. This energy is called the binding energy of the nucleus. Binding energy equals to del mc square. The binding energy of a nucleus determines its stability against disintegration. In other words, if the binding energy is large, the nucleus is stable, and if not, the nucleus is not stable, or vice versa. Mm, The binding energy per nucleon is binding energy of nucleus per total number of nucleons. It is found that binding energy from nucleon varies from element to element. Like, take an example. You have a binding energy of heavy hydrogen, which is equals to 2.23 mega electron volt, and binding energy of uranium 1800 mega electron volt. These both elements participate in radioactive reactions, but their binding energy is different. So a graph is plotted with the mass number A of the nucleus along the x-axis and binding energy per nucleon along the y-axis. I'll be explaining this graph you later. Explanation of binding energy curve and stability. The binding energy per nucleon increases sharply with mass number A up to 20. It increases slowly after A equals to 20. For A is lesser than 20, there exists recurrence of peaks corresponding to those nuclei, whose mass numbers are multiples of 4 and they contain not only equal but also even number of protons and neutrons. Like, take an example. Helium, carbon, and oxygen. They have 2 protons and 2 neutrons. Carbon has 6 protons and 6 neutrons, and oxygen has 8 protons and 8 neutrons. These are quite high and stable. The curve becomes almost flat for mass number between 40 and 120. Beyond 20, it decreases slowly as I increase. You can see in this graph. The binding energy from nucleon reaches a maximum of MeV at A equals to 56, corresponding to the iron nucleus. Hence, iron is the most stable. Binding energy from nucleon instability, here is the graph. The average binding energy per nucleon is also 8.5 mega electron volt for nuclei having mass number ranging between 40 and 120. These elements are comparatively more stable and non-radioactive. For higher mass numbers, the curve drops slowly and the binding energy by mass is about 7.6 mega electron volt for uranium. Hence, they are unstable and radioactive. The lesser amount of binding energy for lighter and heavier nuclei explains nuclear fusion and fission respectively. A large amount of energy will be liberated if lighter nuclei are fused to form heavier one, fusion, or if heavier nuclei are split into lighter ones, fission. This is the same graph I showed you before, but it is in a simple way. Now, I'll explain you this graph. Now in a graph, we can see in the graph is stable in the region of 50 to 80 mass number, and it has the average binding energy per nucleon as 8.5 mega electron volt. Now, in the graph, iron has the highest binding energy per nucleon as 8.8 mega electrovolt. So it is the most stable element, and beyond the 80 mass number, the graph starts to fall and falls up to uranium, which has got the binding energy per nucleon as 7.6 mega electron volt. Also, Also, the repulsion force between the protons in the nucleus is quite high, due to which it is not able to hold the protons together and decays out, and as the radioactivity starts after the mass number 80. So what is radioactivity? All substances are made of atoms. These have electrons E around the outside and a nucleus in the middle. The nucleus consists of protons P and neutrons, and in extremely small. In some types of atoms, the nucleus is unstable and will decay into a more stable atom. This radioactive decay is completely spontaneous. The energy that is released from the nucleus of the atom is radiation. uh, Different types of radiations. When an stable nucleus decays, there are three ways that it can do so. It may give out an alpha particle, a beta particle, a gamma ray. So, radioactivity. Alpha particles. Uh, Alpha particles are made of two protons and two neutrons. This means they have a charge of plus 2 and a mass of 4. This mass is measured in atomic mass units, where each proton and neutron equals to 1. Alpha particles are relatively slow and heavy. They have a low penetration power. You can stop them with just a sheet of paper. Because they have a large charge, alpha particles ionize other air strongly. Beta particles. Beta particles have a charge of minus 1 and a mass of about 1 by 2000 of a proton. This means that beta particles are the same as an electron. They are fast and light. Beta particles have a medium penetrating power. They are stopped by a sheet of aluminum or plastics. Beta particles ionize atoms that they pass, but not as strongly as alpha particles do. Gamma waves. Gamma rays are waves, not particles. That this means that they have no mass and no charge. Gamma rays have a high penetrating power. It takes a thick sheet of metal such as lead and concrete to reduce them significantly. Gamma rays do not directly ionize other atoms, although they may cause atoms to emit other particles, which will then cause ionization. We don't find pure gamma source. Gamma sources are emitted alongside alpha or beta particles. Gamma emission isn't radioactive decay because it doesn't change the state of the nucleus. It just carries away some energy. So at last, particles that ionize other atoms strongly have a low penetrating power because they lose energy each time they ionize an atom. Therefore, alpha particles are easy to stop and gamma rays are hard to stop. And these radiations are emitted by the atoms who wants to be stable and emits until they get stable. Thank you.